Just checking your attendance. I'll go back to that bigger version. Wait for 5 minutes. Hope I am audible to you, both the sections. Please mention your roll numbers in the chat box so that I can take your attendance from there. Am I audible to you?
Yes, sir.
Okay, fine.
Yes, sir.
Well, as I mentioned last class, you can take this soil mechanics, at least introduction part, as a language learning. So in that case, that lettering, word, sentence, and then paragraph making will be helpful to you. Therefore, I'm skipping that clay mineralogy, the part which I just stopped before at that last class. I am starting this weight volume relationship, which will make you a bit comfortable with with Professor Obedur and Professor Narayan. So they will be using this nomenclature, this lettering. This is ABC of soil mechanics in their part. So I am starting with that weight volume relationships. So this part, sorry, this class will cover the soil, which will be defined, which will be characterized as three-phase system. Then based on their constituents of individual phase elements, the basic definitions, and then the interrelationship between these basic definitions, and after that the index properties, which will indicate the type of soil, the possible behavior of soil, the characteristics of soil, right? So starting with the phase system, soil is called as three-phase system. Why it is a three-phase system? Let's say you are taking a handful of soil, clay from anywhere, digging that clay. What you can find? You will find the solid particles. Those solid particles could be moist. So as it is moist, then it will contain the liquid or the water in our case, as well as in between the moist soil particles or dry soil particles, we'll find a lot of void spaces, or you can say the body is perforated. So in that perforated body, in that whole system or soil mass, that perforated bodies are signifying the void spaces or air volume. So the soil in that way is a combination of soil solids, that is a solid phase, moisture, that is liquid, water in our case, and air, that is a free void spaces. So these are the three phases: solid, liquid, and gaseous phase. Gaseous phases are present in normal soil. Therefore, soil is called as a three-phase system. As you have a three-phase system, and some of the phases are mostly defined by their weight as well as volume. So soil as a mass, as a whole system, can be defined either volumetric way or gravimetric or mass system. Right? I hope you can see my pointer, mouse pointer. So here, what I mentioned, the phases and the corresponding constituents of soil mass or soil volume. So soil has three-phase system. In three-phase system, the solid phase, it contains the minerals or decomposed organic matter, or in most of the cases, both the things. Then liquid phase, that is liquid matter. In our case, it is mostly the water. In gaseous phase, it is usually the water. So here it is a phase diagram. It called the phase diagram, soil phase diagram. Please remember this part, this term, three-phase system, that is associated with soil, and this diagram is called phase diagram. Right? Here you have the total soil. It is a total weight. Its total weight is given as W, and its total weight volume is given as V. If we say the volumetric measurement, then this part, if you just segregate this total volume into air or the gaseous phase, water or the liquid phase, and solid, that is the soil particles phase, and this is the phase diagram or constituents if you segregate the whole thing individually. So the top part, that is corresponding to air, so its volume is given as VA. So air volume or air mass can be taken as 0, therefore the weight of air is nothing is given there, so it is a 0. So WA, see, W signifies weight and the suffix A would signify the air, right? Here V signifying the volume, suffix A, it is signifying the air. So it is a volume of air, mass of air is 0. Then this is the water or liquid phase. The weight of water is given as WW and volume of water given as VW. So this water and this air, this air volume and this water volume, they combinedly termed as volume of void, that is given as VV. Right? Now, next the solid, it corresponds to WS as weight and VS as volume. So the total weight of that body is given as the weight of water and weight of solid, as this part contributes as 0. So total W is W, that is a total one, W equal to WW plus WS. Whereas in case of volumetric measurement, the total volume is given as volume of void plus volume of solid, whereas the volume of void can be again segregated as volume of air and volume of water. So in total, VA plus VW plus VS equal to total volume. So this is a phase diagram which describes the constituents volume and volume and weight, and how they are proportioned within the soil mass, right? So if it is a volumetric measurement, then the total volume is signifying as V, which corresponds to the summation of VS, VW and VA. Whereas if it is a mass, weight or the gravimetric measurement, then total weight is W, which is a summation of weight of solid, weight of water and weight of water, air. Ultimately this part becomes 0 and it turns into WS plus WW. Okay, so this is all about weight and volumetric measurement, which is associated with a three-phase system, that is a soil. Right. Now in our surroundings, mostly what we find soil as three-phase system, that is it contains air, water as well as solid. Now, situation may happen when you can have.
Sir,
Yes, sir.
sir, some students are trying to join but they don't able to join.
Why this is happening? I think most of the.
So they told that they joined previous, then they left and not able to join.
It should not be the case. Okay, ask them to join. I am waiting for 5 minutes. I will admit them. Then I will start.
Okay, sir. Sir, they are telling that window came saying that they could not connect to that video call.
So probably that is from their end. This difficulties is from their end, because so far I haven't received any joining request. So I think I should continue.
Yes, sir.
They told that they are trying from another account and it's going same.
Yeah, they can see the recorded lecture.
Okay, I think some of you are recording this lecture. You can share afterwards. I can share the slides as well. Okay, normally in our nature we can find soil as a three-phase system. That means it contains air, water as well as the solid particles. Now situation may happen, you can find the soil as completely dry. That means if you just see this portion, that is the void space. Where void space means the void space within the solid particles, right? So void space are completely filled with air, or that air, or you can say there is no water present in that system. So entire this void space is filled up with air and there is no trace of water. In that case, soil can be treated, or soil will be treated as completely dry. Where someone is trying to join. Wow. No. Okay. Now, thing is that if the soil is completely dry, that means this water part will not be there, and entire void volume will be filled up with air. Air. Now that is corresponding to this phase. So this three-phase system will turn into two-phase system where the water volume will be equal to 0. So dry soil actually represent the two-phase system of the soil, and because of that dry state, how that two-phase system is generating, the water volume or water mass turns into 0, or it is completely dry, right? Now in other case, what can happen, that this air mass can be occupied with water. So this air void can be filled up with water. In that case, the entire void where the water or air can be there, entire space is occupied or will be occupied with water. In that case, what we will say? We will say the soil is saturated. In here, the saturated means the spaces, the void spaces within the soil mass, within the solid particles are completely filled with water. Again, in that case, the soil will turn into two-phase system. instead of three-phase system. In that two-phase system, the air void will be 0, right? And complete void spaces will be occupied by water. So this three-phase system can turn into two-phase system in either sides. In left-hand side, if the soil becomes completely dry, that means water is not there. So volume of water or weight of water is 0. That is two-phase system or dry soil. In right-hand side, if you fill the entire air space with water, then again it will turn into two-phase system. In that case, air void will be 0. So soil either can move dry soil as towards the dry soil, or it can move towards the saturated soil. Yes.
Saturated oil sir আরেকবার বলে দিন।
তুমি কি আমাকে হুকুম করছো না রিকোয়েস্ট করছো?
না স্যার রিকোয়েস্ট করছি স্যার।
Then put your voice in that mode, please. Saturated means something is filled up completely with something. Here, first something is that void space that will be filled up with second something, that is the water. So when your entire void space, here the void space means the space within that volume other than the solid particles, solid volume, right? If that entire void space can be occupied, can be filled up with water, then that first something, that is the void space, is become completely filled up with second something, that is water. Then in that case we will say the soil is saturated with water. Okay.
Sir, in saturated soil two phase, we cannot measure the weight of water and weight of soil differently, right?
No, we can. Wait, someone is trying to join. We can.
But sir, doesn't the soil mix with the water?
What?
So won't the soil mix with water?
No. What I am saying, this is very much ideal situation when I am taking the solid particles separately, taking the water portion separately, and taking the air portion separately. Of course, in nature, you will find the entire thing in a mixed up situation, right? Ideally, I am taking three components individually in a separate way. Okay.
Okay, sir.
Just think it as biryani. I think all of you know the biryani. We have some rice, we have some chicken or mutton or egg, and we have some potato. Let's say potato is something like air void, mutton is something like water, and the rice part is your solid. So we can separate the individual things, right? So we can separate the individual thing to show you, okay, we have some water, we have some mutton or chicken, we have some air, we have some potato, and we have some rice, we have some solid. It is just like that. But in general, when we will eat, we will have or we will buy the entire soil mass, that is the entire mixed up constituents of biryani. Got it?
Yes, sir.
Yes, sir.
When we do have the rice and potato, that we call veg biryani. We don't have any egg or any mutton, right? But saturated thing I cannot explain because that is not happening. So yeah, we can remove that aloo and we can put some extra mutton or extra chicken, so that will be the saturated case. So we can have veg biryani, we can have completely this non-veg biryani without aloo. So that is a saturated soil, and the veg biryani is dry soil. Got it?
Yes, sir.
Okay, fine. So just concept make this particular figure like picture clear. You just close your eyes, think about we have three constituents like biryani, simple biryani. Think about we have three constituents: solid part, rice part, mutton part, water part, and aloo, that is your air. And entire afterwards, entire nomenclature, entire ABCD will be based on these three only. Will be based on VS, VW, VA, and will be based on WS, WW, WA. The entire thing, entire soil mechanics, entire definition, entire lettering is based on this particular slide only. Please make it perfectly like just whenever you close your eyes, you can visualize this one. Okay, moving to the next one. So we have some volumetric measurement, we have some gravimetric measurement. So basic volumetric measurements are void ratio, porosity, and degree of saturation. I am coming into that part gradually. So what we have seen three-phase system which can go either left side, that is the dry soil two-phase system, and right side, that is the saturated soil, again two-phase system. And the phase diagram remains the same as we have seen in the previous slide. So the void ratio, it is being defined, it is noted as E, small e. It is defined as the volume of solid. Mind it, volume of solid, that means this portion, this volume upon VV, that is this total portion. VS over, VS over VV. So this is the total portion, total void space divided by total solid volume. So that is called void ratio. Void ratio defined as the void within the solid particles, right? That void can be occupied by water, that void can be occupied by air, or that void can be occupied by both the water and air. Okay. Then comes the porosity. Now porosity, how it is being defined? It is presented as small n, which is defined as VV by V. This V is total volume. That means total this soil volume, total volume, which consists of VA, VW, VS. So three components. The volume of the three components makes the total V. That is the denominator. Yes, sir. এক মিনিট দাঁড়াও, আমি তোমার কথা শুনতে পাচ্ছি না। VV সমান VW, yes. VV equal to VA plus VW. Here, you just look into this picture. This is the phase diagram. Entire thing is there. VA, this is VV. This is VA, this is VW. This figure is taken from BM Das book. You can refer that book as well. Or this figure is available to every soil mechanics textbook. I have taken this one particular from BM Das book. Okay, so porosity is V, that is the total volume, and this is VV, that is the volume of void. So within that total volume, how much void space is there? The E, that is void ratio, what it is saying with respect to the solid volume, how much is here the ratio of the void space, total void space with total solid volume. Whereas porosity is total void, how much within the total volume, how much void is there? This is total volume. This is the volume of air void and water void. Two are different things. One is you are taking the total volume that corresponds to porosity. Another one, you are taking only the solid volume that corresponding to void ratio. the numerator is same. Right? Now degree of saturation. What I was saying, if something is completely occupied by something, that is called saturated. Now thing is that it may not be completely occupied, then some part will remain void or some percent of saturation we can say. So that is called degree of saturation. So how much that second something is occupying the first something, that is called the degree of saturation. That means how much this total void space, available void space that can be occupied by the water, how much water is occupying that void space is called the degree of saturation. Okay, so degree of saturation is volume of water divided by volume of void, right? So this is the three basic your volumetric measurement. Now tell me, so then there are several interrelationships that you can establish with respect to these basic three properties. Okay, like here one thing is done for you, the E that is the void ratio, which is defined as VV by Vs. Now this Vs can be written as V minus VV, that is total volume minus void volume. Total volume minus void volume. What you are having? You are having Vs. So Vs is replaced with V minus VV, right? Now you just divide the whole thing, numerator and denominator, with V, and you will be having something like N divided by 1 minus N. What is N? That is nothing but VV by V, that is porosity. So this is that interrelationship, or in other way you can present it as N equal to E by 1 plus E. Now think about this degree of saturation. So what extent the degree of saturation can move? That means what could be the minimum value of S, what could be the maximum value of S. So what it is going on there? So VV, that is volume of void, it is not changing, right? It has become constant for a soil mass, right? What can be changed? You can change the amount of water that will be occupying that space. So VW
is 0 and highest 1.
Yeah, 0 and highest 1. So this VW can be 0, that means completely dry soil, or VW can be just equal to VV, that is 1, or VW can turn into 0 or VW can turn into VV. So degree of saturation can go from 0 to 1 or 0% to 100% theoretically. Right? Clear? Now, what extent the void ratio can move? What is the void ratio? Vs. What is the VV?
VA plus VW.
No, what I am saying numerically, what extent similar as degree of saturation, it can go from 0 to 1, right? Greater than equal to 0 to less than equal to 1. So what extent that E can move and N can move?
Sir, while
0 to
VH
infinite.
Sir, when VH equals to 0, it tends to infinity, and VV equals to 0, it tends to 0.
See, okay.
More than 0 to infinity.
Okay, please stop. See, Vs, someone has answered like Vs equal to 0. Vs cannot be equal to 0. Because if Vs becomes 0, then it won't be a soil anymore. It will be either water or air. So without solid particle, it do not have any implication like soil mechanics. Soil, it is not a soil one. Okay, what it can be? Vs can be a very small quantity, but VV can be a very large quantity. Right?
Yes, sir.
Yes. In that case, E should be greater than 0, right?
Yes, sir.
Yes.
Greater than or equal to 0 or greater than 0.
Cannot be equal to 0, sir, because VV cannot be equal to 0.
Yes, right. VV cannot be 0. So E cannot be equal to 0. So E is greater than 0. Now, if Vs as compared to VV becomes very small, then it can go theoretically up to infinite or less than infinite, right?
Yes, sir.
Is it acceptable? The theoretical explanation? VV can be very large with respect to Vs. Something like you just kept 1 teaspoon of soil within a bucket. So bucket is your total volume and the soil amount is very, very small. So with respect to that volume, Vs is very small and that ratio can go nearby infinite. So E can move greater than 0 to less than infinite.
Sir, why VB should not be 0?
VV should not be 0 because you have this soil body is an uncemented aggregate of soil particle, air and water, right? So it is not a solid body, mind it. It is a disintegrated soil mass, solid mass. Now, if you just imagine, if you consider the solid as a spherical one, then you cannot have a completely filled up solid body as soil. There will be some void spaces. You cannot eliminate the void spaces because it is a disintegrated material. It is not a solid body. You cannot eliminate the void completely. Got it?
Okay, sir.
হ্যাঁ তাহলে
যদি ওটা 0 হয়ে যায় তাহলে রক হয়ে যাবে, ওটা সয়েল থাকবে না।
no, even rock is not completely you cannot say rock is a solid body completely. You don't know what is there. It can because rock is nothing but solidified magma, right? Now when this magma comes out from that particular earth crust, earth body, it contains solid, it contains gas phase also. Now during
Sir,
that,
sometimes rocks also contains air pores, right?
yes, of course, because when it gets cooled down to become a solid body, so called solid body, hard rock, it can trap that gaseous body also. Therefore, you just wait for 2 minutes. Yeah, the rock is not completely solid body. It can trap the void spaces, gases within its body. So in that case also, it's very difficult to say whether it is having VV or it is VV equal to 0. The rock, in case of rock, you don't have this kind of lettering system. The rock system, the classification of rock, the nomenclature or this lettering, so-called lettering of rock is different. The analyzing system of rock is not like soil. Okay, in soil, in rock, this void ratio won't work, or it is not associated with rock. It is only for soil. Okay. So what is porosity in that case? What could be the range of porosity? So V is fine. Now VV. Ideally, VV cannot be 0, right? Hello.
No, sir.
Okay.
Yes.
Can VV equal to V?
No, sir.
Yes, sir. No, sir.
No, sir.
In that case, it won't be a soil one. So N should be greater than 0,
0 and less than 1.
1. Right. So please remember this thing. You just observe the nomenclature, observe this phase diagram. Then of course you can mention your answer rightly. Okay. So that is what here one case. This is the degree of saturation that has been mentioned here. Here, when it is going to dry soil, that is two phase, S will be equal to 0. When it is moving at right hand side, that is again the two phase, but it is a saturated soil. In that case, degree of saturation will be equal to 1. Got it? So next, the gravimetric measurement, where this all the quantity, numerator, denominator, all the things will be entirely mass metric or gravimetric or weight related, right? We have only one such quantity, that is the water content or moisture content. See, this water or moisture content, that is the free water. Okay. Now, what is free water? Can anyone answer? What is free water?
After extracting the water from the soil, which water we get?
After extracting water from
Soil
water?
birds. So which water we get? That is?
No. What kind of extraction you are talking about?
Sir,
Yes, what you have said is correct, but what kind of extraction process?
sir, compaction,
No, no,
consolidation.
no, 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 no.
So
You are
water
going too
vapor.
far. A simple mechanics. Yes, yes.
So water vapor.
Yeah, vapor. One thing is vapor, and another thing, it's not actually extracting. It actually free water which can move freely. That can be done if you put some, or if you create some hydraulic gradient. Then from one place or higher hydraulic gradient, water will flow from towards lower hydraulic gradient. But that is not applicable here. Here the vapor only the thing. The vapor, but the vapor, the limiting temperature is 105 at most, or 110, where the water will vaporize. But thing is that if you go beyond 110, let's say 150 or 200, 250, again water will vaporize, but that water will vaporize from inner structure of the soil. Okay. And if you extract that way, that means let's say it is at 200 degrees Celsius. In that case, water will vaporize, or water will be extracted from inner structure of soil. And if that water is being extracted, then the mineralogical composition of the soil particles will be changed, and soil will no longer be a soil. The classic example is brick. The brick is formed from it is being prepared from clay, right? So once it has been burned to a very high temperature, it turns into brick, the clay mold. If you burn that clay mold in a very high temperature, it will turn into a form which is called the brick. Now thing is that if you just make a dust of that brick and you add the water, it won't go back to the clay form anymore, because it is now a chemical change, right? Whereas if you just take a soil and you just try to vaporize it, even in under sunlight, then it will be dried up. Okay. Now again you put some water, it will regain its original shape, original position. It can go back to its original state. So that physical change is applicable in that extraction, but not the chemical change. So that physical change a temperature up to 110 at max, because when the water is in soil, within the soil body, it is not the pure water anymore. So its boiling temperature or vaporizing temperature will increase, which is normally, in case of pure water, it's 100 degrees Celsius. So we keep that 10 degrees Celsius as factor of safety or that impurity purpose. Okay, so that water which will vaporize under temperature of maximum 110 degrees Celsius, that is called free water. And that water, how much of that kind of water is within the solid body, that is called the water content or moisture content of that soil. Okay, so water content or moisture content is the gravimetric measurement entirely, which is defined as weight of water divided by weight of solid for a given soil volume. How you will determine? This is simple. You just keep some moist water, moist soil. This is your moist soil. Let's say its weight is WMS, moist soil. Okay. When you will dry the soil, this moist soil, into oven at a temperature of 105 to 10 degrees Celsius, right? What will happen? The free water, mind it, free water only. I am extracting the free water from that body and it becomes the dry soil. Okay, now what you have? You have dry soil weight, you have moist soil weight. If you deduct these two, then you will get the moisture content. And you just divide that moisture weight, divide by this dry soil, you will get the moisture content. This is a laboratory experiment for you. You will be doing that laboratory experiment in your probably not in this semester, but the next semester probably. This is one of your laboratory experiment. Okay, which is explained here simply. Yes.
So this method is applicable for all type of soil.
Which kind of soil you are talking about? No, not all kind of soil. This is actually what we are considering within that 110 degrees Celsius, that range, the organic matter which is there, we are not disturbing that organic matter. This is not valid for organic soil, peat kind of soil. There, the composition is little different. The organic matter may burn within that degree, within that temperature. In that case, it is not truly applicable. I should say the term truly. Okay. What we are assuming here, the solid part of that soil remains same. We do not have any alteration in mass of that particular solid. We are only vaporizing the water from that body, and that vaporized water divided by the dry soil or the solid particle, that gives you the water content or moisture content. Sometimes when we have a very high organic content within that body, in that case, some of that organic matters will disappear, means it will vaporize at that time itself. In that case, special consideration has to be taken, or it has to be mentioned there, that observation that it is having highly organic matter composed thing. But that moisture content term will be there. You will measure the water content or moisture content in a similar manner. Simultaneously, you have to have mentioned that it is an organic soil. Then, who will read that report? He or she will understand. Okay, fine. Some of the organic matter may have bound it into within that particular duration or within that particular process, right? Okay. Generally, this water content or moisture content is expressed as percent, 100%, 20%, 10%, like that. Okay. Can you say whether water content, what could be the range of water content?
Theoretically, it should be 0 to 100%.
Why 100%?
0 to infinity.
Here more than 100% if the amount of moisture is more than the amount of weight of soil. Sorry.
Yes, 0 to any amount, any positive amount. See, I can remember I was mentioning some bentonite last class. So bentonite is a manufactured soil. It is a very expensive soil. It can contain the water, or its water content can go up to 800,000 times of its own weight. So the water content or moisture content of any soil can go up to theoretically it can go up to infinite. It runs from 0, right?
Yes, sir.
Okay. Okay. Now there are combination of weight volume measurements. We have some combination of weight volume measurement associated with our soil mechanics basic definitions, like unit weight, which is nothing but weight of soil per unit volume. Simple, mass per unit volume. Bulk or total unit weight, when that mass per unit volume, that mass is a bulk mass or is a total mass which contain air, moisture as well as solid particle. Okay. Dry unit weight, again it is a unit weight, but where the numerator, that weight of soil, it is the weight of solid only. This WS do not contain the weight of water. Okay. It can be expressed as gamma B for bulk. Some books, or you can also mention it as gamma T for total. Some book has taken that nomenclature gamma T, that is total or bulk unit weight. So gamma B or gamma T is same. Sometimes people only mention gamma. That also considered, or that also implies the bulk or total unit weight. Please remember these conventions: gamma T, gamma B, or simple gamma. They simply implies the total or bulk unit weight. When you are mentioning huh?
Is it weight or is it density?
Which one? This is unit weight.
Sir,
Gamma.
sir, but the formula defines W by V, which is average density.
Density is mass by volume.
Oh, weight.
Rho. It is weight.
In newtons, right?
Got it?
Yes, sir. Yes.
That is actually, you're right. Correctly mention the wrong thing. It's very confusing, and people are often make this error in their answering. Please remember what I am mentioning, whether it is weight or whether it is density. Because the thing is, okay, numerical value, there may not be any change, but the thing is the unit. In case of unit weight, it will be kilonewton per meter cube. In case of density, it will be gram or kg per centimeter cube or meter cube. And thing is that almost 80% of you, even me, or 80% of the people, they have this confusion, or they put simply the unit weight and density in a similar manner. It's non-intentional, but it counts as something we are making the density and unit weight in a same way, but it is not. In case of density, it is not associated with G, the gravitation. In case of unit weight, it is associated with weight. That means you are considering the gravitational force. Please remember this one. Even most probably, I have also mentioned the density or unit weight mass in a similar way in my previous slides. Maybe. If I mention, I was wrong. So gamma B, gamma T, or simply gamma is the total unit weight, whereas dry unit weight is the weight of solid particles only divided by total volume that you can mentioned as gamma B by 1 plus W, or water content. Now density, it is expressed as rho, which is mass by volume. Okay, to establish the other interrelationships, okay, other interrelationship between the other parameters, our only assumption is Vs, that is volume of solid, is equal to 1. Once you have assumed the Vs equal to 1, you can explain all the interrelationships. See, this is your phase diagram where the Vs is kept as 1. If Vs is equal to 1, here you can see the E, which is nothing but volume of void by volume of solid. If Vs become 1, then E is equal to nothing but Vv. That means this total thing is becoming as the void ratio. Simple. And you can go ahead with defining the other interrelationships. I would request you to practice these interrelationships. You can find this interrelationship with their explanation or solution, how you can reach to that particular relationship in every textbook. Almost every textbook has solved that interrelationship, the procedure, how to reach that interrelationship, and you please practice that one. One thing, if I am asking you, you should solve it with phase diagram. You have to start from Vs equal to 1 with that phase diagram. Mind it, if I am asking you to solve any of that interrelationship with respect to three-phase system phase diagram, you have to start from here. This diagram, then assumption you have to mention as Vs equal to 1, and then you proceed. If I am not mentioning anything, you can go with any of that proven relationships. Let's say I am solving this one or that one. You can use to solve that relationship with any of the already proven relationship, basic one, without explaining the three-phase system. But if I am asking with the help of three-phase system, then you have to start from very beginning. You please practice this thing. See why I am asking you. Okay, this is only for, I should not say, but I have to say, this is for your exam purpose or your this competitive exam or semester exam purpose. I never have had practice this one, remember this one, because these are proven. This can be found in books, but you should know how to solve that one. Let's say this is that expression. If you need to use this expression, if I am the examiner in your semester exam only, not in external or any other competitive exam, I will provide that expression. You don't require to remember that expression, at least for my exam. But you should know how to define that one. But you have to remember, or you have to practice this expression to be practiced, or as per the answer, as required as answer. Thing is that you should not remember this kind of large expressions. I'll provide you in your exam. Don't worry about that. You should at least remember these things. Once you have practiced these things, the basic things, you have these basic things, you can solve any of the things. See, it is very simple. You just process what is your requirement. You just know the process. I will provide you large equations. If you require, I will provide you with your question paper. Don't try to remember this waste thing. It is available to any printing media. It is available in any soft media. So don't try to remember this one. I will provide you, but I don't know what will happen in competitive exam. For safety purpose, you should know these basic things. Okay, then I am moving to my next portion, which is called the index properties. Sorry.
Sir, the G factor given for capital G.
Oh, sorry. Yes, this G is your specific gravity of solid.
Okay.
Fine. What's the time? Can you allow me 15 minutes?
We have class from 4:30.
Sir, we are having a class.
Okay. Fine. Thank you then. You please mention your roll numbers in the chat box. Okay, that will be treated as your, what is that? Attendance.
Sir, the book named Gopal Ranjan now is good for our syllabus.
Yeah, you can use Gopal Ranjan book, you can use BM Das book, you can use Murthy's book. These are the three priority based books for me. There are several others like Alam Singh, there are Purushottam Raj, several books are there. Okay,
What about Bishi Punmiya?
Sir, our BC full me
Sir, this is calling that it is only on soil mechanics, and does it not mention the foundation part? And
sorry.
soil mechanics means the first part of the geotechnical.
Yeah, soil mechanics implies the first part of, yes, geotechnical one, basically. Not even the first part. It is a first part. All those textbooks, except the BM Das book, they have the foundation engineering and soil mechanics as a combined form. BM Das, they do have geotechnical engineering and foundation engineering in separate volume. At least the volumes that is available in Indian market.
In VNS Murthy that you have said, that also includes both.
Yeah, in VNS Mukti, the title itself is soil mechanics and foundation engineering. For you, undergraduate level, there are several other title from VM Das which deals the advanced things. But for you, the soil mechanics and foundation engineering by VNS Murthy, the geotechnical engineering by BM Das, the soil mechanics by soil mechanics and basic and applied soil mechanics by Ramaranjan. These three books are my priority. BC Punmiya, of course, you can use, but I do prefer that BC Punmiya as reference book only, not the textbook. That is personal opinion, absolutely.